Good afternoon. This is a demo that I've been wanting to record for quite some time. There has been a lot of requests to provide some user guide, some documentation and clarification really around BIG-IP clustering that is ultimately primary and secondary or active standby BIG-IPs front-ending a Kubernetes cluster. And specifically around the concept of using the Flannel Networking Fabric. And so we've had a lot of documentation, and there is some documentation written out there about using the Calico Network Fabric. But this document is really focused around BIG-IP clustering using CIS, front-ending Kubernetes, specifically using Flannel. And there are some very specific requirements that you need to be aware of when you're using Flannel. And the reason is because Flannel is a overlay fabric that is using VXLAN. And within VXLAN, we have something called a VNI, which is really our specific forwarding networking or forwarding network, if you want to call it. And we don't want to go into too much detail about VXLAN in this demo, but what's really important is the configuration of the fabric is actually quite significant. And what we need to do within BIG-IP to make sure that high availability works correctly is really important. And so it's very different than potentially dealing with OpenShift and the OpenShift environment. So let's talk a little bit more about it. And one of the reasons is because of the way that Kubernetes and Flannel works with OVN or OVN Kubernetes, the overlay stack. And so as you can see in this diagram, we have BIG-IP1 and BIG-IP2. These two BIG-IPs are configured as a cluster. And there is manual sync between these two BIG-IPs. And so what's so significant is that each BIG-IP really has its own CIS. And so these CIS, they're really identical in the way that they communicate with their BIG-IP. So in this case, we have BIG-IP1 and we have CIS1, we have BIG-IP2, and of course we have CIS2. And you can see the control plane happening between each BIG-IP. So the CIS instance is really updating the BIG-IP. So the BIG-IP itself will always have the configuration. And so you can see here as the CRD gets created in Kubernetes, CIS will then update its unique BIG-IP. And so that configuration is pretty trivial, and as you can see there are examples that talk a little bit about this configuration. So for example, the target for CIS2 would be BIG-IP2, and the target for CIS1 would be BIG-IP1. And then each CIS could listen to a CRD, which would then get populated to the two BIG-IPs, and then of course the specific data plane would be the pod directly, in this case because it's Flannel. However, only one of the BIG-IPs would be active at this specific time. So let's go and take a look at the BIG-IPs. And so as you logged in to the first BIG-IP, BIG-IP91, and as you can see, this BIG-IP is active. And in this environment, I have already configured the CRD. What I've also done is I've set up the tunnels and I've set up the self IP. So you'll notice that we have here, let's take a look at our tunnels. We can see our Flannel configuration for the tunnel here. That's just a profile name. This is the physical IP address that I assigned to the BIG-IP. The documentation, the user guide explains pretty much all of this. Let's go into the second BIG-IP and take a look at what the second BIG-IP looks like. So taking a look at the second big IP, let's go down to the network and take a look at the tunnel. So you can see that this one here is referring to itself. So the tunnel is created, and I referred it to its local address. So pretty straightforward. Created the tunnel, and you can see there is 4 database entries on both of these tunnels. So I know that these 4 database entries are actually working because they're on both tunnels. Now, here's what's really important. When we configure high availability, we're actually going to disable the syncing or the synchronization of the forward database entries when we do a manual sync. So when we sync the configuration between the 2 big IPs, we're not going to sync or share this information. We actually have to disable that. For the solution to work, these forward database entries have to be left alone. And so that's really important. If we go and look at the diagram, you will actually see that in the diagram itself. So as part of the solution, that the first major step is to actually set this DB value so that we do not sync any of the information across the tunnels itself, and so that all config sync across the tunnels is disabled. And so this is really important. You need to make sure that if you're going to configure the solution, that this value right here is disabled. If you do not do this, this is not going to work. And so there's some information there. So I've already done that. In my environment, my variable is disabled, so that there's no syncing between the 2 big IPs of any of the tunnel information. And the reason it's not necessary to sync, because each CIS can update its own big IP. The second thing is to create the dummy node. The dummy node is so that you can just see the node. We need the node within Kubernetes for Kubernetes networking as it participates in OVN. And you can see that I've created the two big IP dummy nodes in this case here. Here is the first one, and then of course there is the second one. You can actually see if you actually go into Kubernetes itself and do a kubectl get nodes, you'll actually be able to see it. So kubectl get nodes, you can actually see there are my 2 dummy nodes that I've created in my Kubernetes cluster. And so you can actually take a look at those 2 files, and I've created those files here for you. You can see there is the first one, and that is the MAC address from the profile, from the tunnel. And of course there is my pod CIDR, which I've created. And of course you can see the second one as well, which I've created as well. And there is the second example. So that's the two dummy nodes that you need to create. Of course, we talked a little bit about creating the self IPs. You can create the self IPs right here. Self IPs is quite unique. Make sure that when you create the self IPs, you give it a unique. In this case, I gave it a unique address here within the subnet itself, and which actually worked quite well. So if we go back to the big IPs and take a look at the self IPs, you need the self IP here is what's really important, because this self IP is an IP address in the Flannel CIDR, right, in the Flannel network. And so the reason for this is so that big IP can be part of the Flannel CNI. And so that's why big IP has to have a IP address, self IP, on that overlay. And as you can see, there's the first one, and we'll take a look at the self IP, and there is the second one. I've just used 9192 again. This time I just changed the third octet, just rep the third octet for the second device. So as you can see, I created the CRD, and so I went and just did a kubectl create, and I created the CRD. So we got one CRD which gets populated to both CIS, which then pushes the CRD to the big IP. And if I change it to the Kubernetes tenant, you can see there is the virtual. and I'll do the same on the standby. We go to the virtual address, change to the Kubernetes tenant. You can see the same virtual address. However, traffic is being serviced by the active device, and we can see the F5 demo right there. Okay, excellent. So what we want to do now is we want to generate a failover, a very simple failover. What I'm going to make sure we do, I'm going to set up a simple ping. I'm going to ping the virtual from the network to make sure that there is 0 packet loss as we fail over between the primary and secondary, and then fail back again. And so what I'll do is I'll start this ping. So as you can see, we're pinging the virtual address. It's that same virtual address .12. And so we'll monitor that ping as we generate the failover. So let's go into the primary device here. I'm going to change back to common, and I'm going to change this back to common. And we'll go into the standby, and we'll go here into the active, and we're going to force this to standby. And you'll see we're going to watch the, you can see the ping request. We will test the traffic, make sure traffic is working nicely. You can see this has gone to standby, and this has gone to active. So as you can see, I failed over BIG-IP's front end, the Kubernetes cluster. There's no traffic, no ping drops, no traffic delays. You can see everything is working really nicely across the VXLAN tunnel. So that's really interesting. So let's go ahead and, why not? Let's go ahead and fail back again. So right now we are on the second device, 92, which is my second device. What I want to do is I want to force this back to standby. I'm forcing that back to standby. And so what we'll see is we'll see this device becoming active. And okay, we saw for a split second there was one ping that failed. That was for a split second as that went back. I'm okay with one. I would prefer to see none, but of course you can kind of see as we flip back there was one ping failure there. And of course we can go and test this traffic again, and as you can see, application worked fine. So as we failed back, there was one ping drop. It could just be from an RPing perspective, kind of hard to know, but we can go ahead and test that again. What's really important here, when you follow my user guide, there are a couple of caveats at the bottom, and I want to share the caveat with this solution. So it's very important, the disclosure. So the solution only works if there's no floating addresses. So what does that mean? That means that traditionally in a BIG-IP HA cluster, we create a floating address, and the floating address is normally what you would use for like a default gateway, or if you wanted to create a floating address on the, let's call it the public side, the public facing IP side, you would create a public IP, you would create a floating address so that you can really just point to a shared address for both devices. So if you want to configure this solution, you cannot create floating addresses. If you create a floating address, the solution's not going to work. And I tried multiple different things, and it won't work. You will notice that in the OpenShift HA configuration for OVS Kubernetes, which is using default VXLAN, the floating addresses are quite important. So no floating addresses really allowed in this environment because it won't work. So that's a challenge for me because my Kubernetes nodes are pointing to the BIG-IP as their default gateway in this case. And so external traffic could be a challenge. And so what I've done is I've created a simple virtual address as a default gateway, which captures all my outbound traffic. And so by creating that virtual address on both devices, that takes care of my floating address. So I really don't need a float in this case if I'm just creating a virtual address that lives on the BIG-IP, on the active BIG-IP that will handle outbound traffic. And it's just a simple IP forward. So it's almost like a route, if you want to call it a route. In my case, I called it default gateway because that's what it's working as. So let's go ahead and recap. So as I've shown today, this demo is CIS and BIG-IP HA, BIG-IP cluster configuration using Kubernetes Flannel. And so I talked a little bit about the caveats, having to disable all of the tunnel synchronization or replication of the tunnel configuration. We disabling all that. Also talked about having no floats, and then the configuration that is required for the self IPs. That's pretty much all it is. I hope you enjoyed this video. Thank you.